Today we'll be talking about the 15th question in the NHT paper in the network section. The network below shows one-way paths between the entrance and the exit of the marketplace. It connects to a previous question. The vertices represent the intersections of the one-way paths. The number on each edge is the maximum number of visitors who are allowed to travel along that path per minute. First question says, when considering the possible flow of visitors through the marketplace, many different cuts can be made. Determine the capacity of cut 1. So we are now looking at this particular cut, okay? So what I usually do is I indicate as to where the edges that this cut cuts and only look at those values. Now, if it is an edge that goes from the source to the sink, okay, in the forward direction, you include it. So that's, you include 12. If it goes from the sink to the source in the backward direction, you don't include it, okay? Now, this one clearly goes from source to sink, include that edge. This one goes backwards, don't include it. And this one goes forwards, include it. So if you were to look at the values that you would include, they would be 12, 10, and 12. When you add them up, you will get 34. Now the next question says, determine the maximum number of visitors through the marketplace from the entrance to the exit. Now there are many ways to do it, and I think across my videos I've explained a few different methods. One of them is setting each path, writing down all the different paths that go from the source to the sink, and just adding all the lowest values along those paths that can flow through. I think what I'm going to explain is something very similar. And so the very first path that we will look at is this one, the lowest value along that path. And we can see that the lowest value along that path is 8. So we write down 8 and we take away 8 from 8, and that gives you 0. That gives you 4, and that gives you 6. So it's important to record it, and what I usually do is I also highlight, okay, those paths which have reached maximum capacity and no more visitors can go through or flow can go through. The next one we look at is along, so we have to come systematically downwards. So I can see this one, okay, and in that path 4 is the lowest value. So I record 4, I subtract 4 from 4, and I get 1 here, I get 8 here, and I get 6 here. So the path that I took was, that leaves me with 2 here, a capacity. So that means that I can't go across this path anymore. So what that tells me is that though there is 1, okay, that can flow through here, it's no use because it will come to a maximum capacity edge which won't accommodate anymore, and so I can take away that edge for future reference. Now the fact that nothing can flow through AB tells me that this edge BD is of no use either. Okay, now let's look at values. We look at now this path, okay, and the smallest value along that path is 6. So we take away 6 from 6. That leaves me with 2, and that leaves me with 4 here, and so we write 6. So the path that's reached saturation here is this one. Now that tells me that if nothing can flow through xc, then even though there is a capacity of 2 left over here, okay, nothing can flow through that, and so that particular edge is of no use to me as well. And so we can now actually, no, that's not right, because we can still come this way, okay? And so what we do is we then look at that particular path, that is this one, and the smallest value along that is 2. So we subtract 2, and that gives me a 0 here, and that gives me 2 here. We write down 2, and so that then leaves me with 6 here, 10 here, and 10 here as well. So as we've shown previously, I had indicated we've actually reached maximum capacity along here. So that implies that if nothing can flow through this edge, this is quite meaningless, okay? So we cancel that. So now let's look at the edges that we can actually have any flow through or visitors walking through. So we look at this edge now. That's the only one that seems to remain. And so maximum capacity that can go through is this value, 9, which is your bottleneck over there. And so we take away, we first write 9, and then that gives me a 0 there, that gives me a 1 here, and that gives me a 1 here. Now that particular edge has now become, so we stop there and we add them all and we get 29. Are these the only paths you can take? No, not really. All you have to remember is you come from the top edge to the bottom edge systematically. You could actually take different paths. I've taken these. Now you could try, as long as you're coming top down, you could actually take different paths and you will reach the same answer. Thank you. Bye.